A quadratic factor that does not factorize. We are asked to resolve into partial fractions 4x squared minus 4x plus 13 over x minus 2 times x squared plus 3. So I have a linear factor in my denominator as well as a quadratic factor. And if you have a close look at the quadratic factor, you cannot factorize the quadratic factor into factors which are real numbers. This is why the heading states a quadratic factor that cannot be factorized. So we're going to immediately resolve them into the partial fractions. So my first fraction will be a over x minus 2. My second fraction is the fraction with the denominator x squared plus 3. So I know my denominator must be x squared plus 3. And my denominator is quadratic. So my numerator will now be linear, and I write it as bx plus c. And the reason why is, if I may just do it on the side of our page, we know that if you take a linear expression multiplied by a linear expression, you would get a quadratic, because x to the 1 times x to the 1 gives you x squared. Going back to my question, this now must equal to my fraction, which is 4x squared minus 4x plus 13 all over x minus 2 times x squared plus 3. Now, I can immediately find my LCD and try and find the values of a, b, and c. But once again, if you have 3 unknowns in your numerator, rather try and use the cover-up method for any of the linear factors in your denominator to help you to find one of the values of your numerator. So I can only use the cover-up method for the linear factor a x minus 2, and so if I do that, I will find the value of a. So once again, I know that if x minus 2 is a factor, then x equals to 2 must be substituted into the fraction. So I cover up x minus 2 and I substitute x equals to 2 in the other values of this fraction. Right, so I'm going to do the substitution in another color. So I'm substituting x equals to 2 because my factor is x minus 2, and I've covered up the factor x minus 2. So I have 4 times 2 squared minus 4 times 2 plus 13 all over 2 squared plus 3. Right, and we quickly calculate this. This gives us 2 squared is 4, 4 times 4 is 16. Subtract 8 plus 13. And remember, this is going to give me the value of a. So I got 4 plus 3 will give me 7. And in the numerator, I have 21 over 7. So I've got that the value of a is 3. Substituting a equals to 3 into my fraction, I have 3 over x minus 2 plus bx plus c over x squared plus 3 equals to the given fraction, which is 4x squared minus 4x plus 13 over x minus 2 times x squared. Right, so I know my lowest common denominator is going to be x minus 2 times x squared plus 3. So each numerator is going to be multiplied by the factor of the LCD that is missing. So in the first fraction, I have 3 times x squared plus 3. bx plus c must be multiplied by x minus 2. And this gives me 4x squared minus 4x plus 13. So now I need to multiply, so I get 3x squared plus 9. Apply the distributive property here, so I got bx squared minus 2bx plus cx minus 2c equals to 4x squared minus 4x plus 13. So I need to find the value of b and c. So looking very closely at this, once again, I'm going to try and find it as efficiently as possible. So to find b, I'll scan across and I have 3x squared, I have bx squared, and I have 4x squared. So with the variable x squared, the only unknown is b at bx squared. So what I'm going to do is write this as an equation. So on the left-hand side, I have 3x squared plus bx squared. So I got 3x squared plus bx squared must equal to 4x squared. Once again, I ignore the variable and concentrate on the coefficients. So 3 plus b equals to 4, and I can simplify, and I see immediately that the value of b is 1. To find c, I have two options. I can consider all the terms that contain the variable x. So I have minus 2bx plus cx equals to minus 4x. Or I can take all the constants. So I have 9 minus 2c equals to 13. That seems to be the quickest method, so let's take the constants. So if we equate all the terms with the constants, I'm going to highlight this in a different color so that you see what I'm doing. So I'm going to take 9, highlighting 9. I'm going to take minus 2c, and that's going to equal to 13. So I'm equating all the constants. Right, so we have 9 minus 2c equals to 13. And if we solve, we have minus 2c, 13 subtract 9 is 4. So c equals to negative 2. So all I need to do now is substitute the values of b and c because I've already found a. And I know that a is 3, and this is the first fraction. So I have 3 over x minus 2. b is the value of 1. c is minus 2. So I have, my numerator now is x. So the numerator is x minus 2. The denominator is going to be x squared plus 3. So these are the partial fractions. And if I add those two partial fractions, I get the fraction 4x squared minus 4x plus 13, all of x minus 2, x squared plus 3. So instead of doing complicated simultaneous equations with 3 unknowns, rather use the cover-up method to help you to find one or more of the numerators. But remember, you may only use the cover-up method for a linear factor or a repeated linear factor.